Hi folks, this is the video solution for the assignment 7 in the afternoon lab, and you're supposed to use your own dimension to create a mechanism like this. And basically, as the rod is pushing to the right, it makes this wheel roll, and when it rolls, is this tilted link is going to go up and down that slot. Now, uh, the different ways of doing this thing. Many different ways. But what I'm going to do is I'm going to create a slide curve between the pin here of the wheel and that opening in the tilted link, and then a roll curve between the circle here, the wheel and the ground, and a prismatic joint between this rod and uh, uh, that piece. Now remember, this top pivot point and these bottom ones are okay. So what I'm going to do is basically this top wall to top support, and these two are going to be in the same part. Okay, and I'm going to fix that. So let me go here. Let's start with the product file. Okay, so insert. Let's do uh, the the support, the wall supports first. New part in there, and I'm going to call this thing right click properties. I'll call it how about base. Let's make it. On that top, we're going to sketch. I'll do a few things, draw a few things. One of them is, for example, a circle like that. Let me undo this. Well, I really wanted that thing to be on that line. That's not a requirement, but that's what I was planning, and I'm going to do it. So this is going to be the okay, that's good. And then a rectangle over here. Over there. This is going to be the left wall, basically, part of the base. And then there's going to be another one down here. This is where the wheel is going to roll. Let me do have a cleanup of these if necessary. Let me see. Yeah, that looks good. Okay, good. Let me just make one dimension here so that I have an idea how big these things are. So, oh, not that one. Delete this guy. I want to have an idea. So I'll make this thing 0.25. How about that? 0.25. Okay, good. Exit. I'm going to pad all of this by 0.5. Okay, very good. Let us go and do the tilted link next. So insert, new part, tilted link. Let's make it. Okay, so on that on that plane, I will sketch. Why don't I project this guy? Okay, and I do the rest of the link. How about me doing elongated hole? I like that. Okay. Now I need a pathway in the middle, so why don't I try to make it? You do this thing any way you want. Okay, I just didn't want these things to be tangent to each other. There's no reason I won't. Yeah, let me not make them tangent. Control Z, Control Z. Okay, good. Let's try it again. Yeah, that's fine. Exit. Okay, and then pad it. Why did I make it 0.5? 0.5, 0.25? I can't remember. Yeah, okay, fine. This is fine. All right. Now we're gonna go and insert the wheel. So insert a new part in there. Make it. Okay, so on a convenient plane, on that vertical plane, I will sketch. Okay, a circle. It's gigantic. That's fine. Okay, I want this guy to be on that line. So that control this to be coincident. Okay, and I want this curve control that curve to be tangent to each other. Tangent, right? There we are. Okay. Yeah. Actually, I want this thing to be a little bit bigger. That being the case, I have to delete this constraint, make it bigger. Yeah, that's good. Okay. And this is fine, except that, yeah, that's fine. That's fine. So let's make this a little, why don't I pad this, exit, pad it, 0.25. Okay, that's fine. And then on this face, I will sketch a little circle. Why don't I make this thing the same radius as that? Actually, that's okay. I'm just going to leave it the way it is. Exit, and then pad it. I don't know what this distance is. This distance was 0.5, was it not? This was 0.5 when I originally padded it. So I'm going to pad the sky also by 0.5. We may have to go and fix these things. Just keep that in mind. Okay. All right. Yeah. Okay. Very good. Now, the next thing is we go here. Insert the rod. Insert, this is the horizontal rod I'm talking about, this guy. So insert a new part. Rod. Properties. Rod. And rod. Okay. Let's go make it. So we go there. Double click. Okay. So let's check this thing. What do we have here? We have a revolute here, right? Okay, so that's good. On that plane, I will sketch. Okay, a rectangle. Okay. Now we do have to make a little bit of a cleanup. I need to put let me see for a second. Yeah. Okay. So this is fine, but let's go to that wheel and make something. Let me pad this thing. 0.5 or 0.25 actually. Okay, that's fine. Now here, on there, okay, on there, I will make a in that same part on the rod. Let me go there. So that sketch. Let me go to that sketch. Draw a circle. Here, draw a circle there. No, come on. It's too big. Where is this? I'll put it there. Okay, what do I put this thing exactly halfway between? Nope. Let me make this circle, control that circle, concentric. Okay, fine. Smaller. Okay, and this rod, if we want to make it look better, like so. Okay, and make it longer this way. Okay, so let me put this, control that. Coincident. Okay, very good. Exit. There we are. Okay. Okay, that looks good. Okay, so we go all the way to the top. We're going to start assembly process. I think I have all the pieces that I want here. Let us anchor first of all uh, the the base right there. See that? Anchor this. Good. Let's move things apart so that we can see what's going on. So here, translate this guy in X direction, and this thing in X direction, and this thing in X direction. Fine. Okay. Can I assemble this on that? So coincidence. Where is that? Coincidence between this axis and that axis. I think I did it. Did I not? Yep. Good, good, good. Coincidence between this plane, and I think the way I had drawn it was in that plane. Okay. Update. Good. That's the way I had drawn it. Very good. Now let's bring this guy and put it on that surface. Okay. So contact between this plane and that plane. And if it doesn't look good, we change it internal to external. Okay, I don't know. It doesn't look good. You can see that when you look at the view from. So that, go back to that last one. Change this thing from internal to external. Update. Shift it up. Yeah. They are level. You can see that. Now, why don't I bring this surface, control, that's right, coincidence between that face and that face, update, good, okay, all right, we're almost there. Let's bring this thing and put it there. So, for example, I can say, once again, contact. Anything that we don't like, we're going to delete. Going to delete later on. Contact between this and that. And if it doesn't look good, we change external to internal. That looks good. It looks good. Okay. Now we come to this piece. So this piece is, let's see now, coincidence between that axis and this axis of this disk. Okay. And we put this thing on that surface, coincidence between, I think it was, let's try it like that. I think, yeah, that face and this face. Update. Okay, it should have been actually the faces are wrong. Let me delete this, delete that. You know what? Actually, we don't have to delete it. We can just flip the arrows. Oh, wrong side. Wrong side. Okay, so now I'm going to delete it. Delete this. So let's do that. Coincidence between this face and that. That face. Update. Okay. All right. Let's see now. Does that look good? Yep. Okay, so let's actually see whether we can make this thing move the way we wanted it, but it may not. So we'll find out. So we do manipulate, respect the boundaries, translate in the direction Y, this piece. Yeah, actually it does work. You can see that. And you can see that that wheel is rolling. Very good. So that's good. Now, there's no guarantee. Now, the only thing is that notice that I was kind of careless when I made these sizes so that it looks like that guy is going through that, which is actually true. It is going through it. If you don't like it, just make sure that you change the sizes so that it looks more respectable. That's all. Undo. Let me put it back where it was. I did a sloppy job making that thing here, the size of that, but it's okay. So now we're going to go to digital markup. Any joint that is not created, we're going to make it. Okay, so be aware of the fact that some of the joint may not be what we want, and we're going to have to do it manually. So we go to Start, Digital Markup, DMU Kinematics, get the magic wand out. New mechanism, auto create. You can see that there's some unresolved pair. That's because of those contacts and things like that, and we have to fix it. Let's check what we've got. Anything that we want to keep, we're going to do that. Things that we don't want, we're going to delete. So, revolute between base and tilt. That we want. Okay, no problem. That we want. This planar, I don't want. I'm going to delete it. Sometimes these you can leave them there, but it's not going to have an effect. Don't delete the children in case you ever have to need it back. Another planar, delete. And this cylindrical, that's okay. You know what? I'm going to delete that. These joints I'm going to create manually. Okay. We already have the only revolute one that we have is correct is over there. Okay. Now let's make a revolute between this and that. So revolute between this and the disk and the plane of this piece and the plane of the disk. There. So there's a revolute there. Now we want a prismatic between that guy and this guy. So prismatic between this plane, line and this line and this plane and that plane. That's going to be a prismatic joint. Let's find out. It says we can't do it because over constraint. I want to know why. Yeah, because remember I created a revolute here. It looks like this is not flush with that. So I have to go back to that. What is that thing? This was the base. Make sure they can be tangent to each other. So this line control that line. Make them coincident, not tangent. Good. exit. But now we can do that prismatic join. Let's try it. So go back to the EMU. There we are, prismatic. Okay. Between this line and that line and this plane and that plane. Yeah, no problem there. It made the prismatic join for us right there. Now we want slide curve right there, slide curve between this curve and that curve. This pin seems to be a little bit bigger than that, but that's okay. We don't care. I mean, obviously you can see that they kind of interfering each other because that should have made this thing a little bit smaller. No problem. And I want a roll curve between these two. A roll curve between this and that. And okay. Degree of freedom is 1. Perfect. So we're going to make this thing angle driven, length driven. So this prismatic, for example, we can make length driven. Where's the prismatic one? Right there. Length driven. And it is moving that way, which is fine. The range of motion is terrible. 0, I'll make it to maybe 1 inch or something like that. Maybe that is. Okay, so let's find out. Simulation with command. When I drag this bar should go to the left. That wheel should roll on that ground. This pin should slide in there, and of course the tilted link will move. So let me see. See that? That's good. The only thing, unfortunately, because of the size of these things that I made, these things go through each other. No problem. As far as the mechanism is concerned, this is perfectly okay. It's just that I did a sloppy job in making these sizes. Okay. Now, you know what I'm going to do? This range actually, I'll go between 1 and because I want to make later on, I want to make a simulation. I want to see what is a good number so that things don't cross each other. 0.3, highest value 0.3. So let's see. Yeah, okay, that's good. Okay, good. 0.3 is what I want. So we go to simulation. We go to 0.3, it's already there. You drag it all, oops, where's that? You drag it all the way to the right, insert, rewind, and play it. And play it continuously so you can see what's going on. Let me hide the tree here, F3. Oops. Yeah, okay. So, there, hide the tree. I play it continuously. We can see faster. Let's make it faster. You see? This wheel is rolling. You can see that the coordinate system is rotating. It is rolling. This is prismatic. This guy is sliding. Yes, I did a sloppy job. These things are interfering, but it doesn't know. As far as the mechanism is concerned, this curve slides on that curve. All right, so you can be rest assured that on the final exam, you will be a problem that you'll ask to choose your own dimensions. And when you do that, you have to be a little bit careful because if you had done this on the final exam, you were in a perfect score, perfect mark, okay? All right, good luck.